Hey guys, this is going to be homework helper number 2, and so I'll be going through some of these problems for us to be able to hopefully, get to understand it through the end. So it says in exercises 1 through 20, graph the given relation, and there's different ways to do it. Like on number 1, when we're graphing this relation here, it's just a set of points. I'm not going to graph all the points, but it's just the idea that you need to take those points like -3, here's 9, let's say that's 9, you'd plot the point, -2, 4, right? You just go through and you just plot all the points all the way through until you get your image. Number 3 is a little different. And so we just kind of have to, because this is like in that set builder notation, it's saying the point is M to M. And then it defines what my M is. And so defining what my M is, if I say M is 0, that means I plug in 0 and then 2 times 0. And so my first point is going to be 0, 0. The next it says my M is plus or minus 1. So for one of them, I'm going to say my M is 1 and then 2 times 1. And so my point's going to be 1, 2. And then if I plug in the -1, I'm going to get -1, and then 2 times -1 gives me -2. And so you're supposed to do that. You just take the values for m's that they have here, you need to plug it into there, and then you get your set of points that you're then going to go ahead and graph. And so, 0, 0, here's 1, 2, and then it says -1, -2. And so on and so forth, and you'll be able to find all the points doing that. And so the same thing goes for these. It's just defining the first one is whatever k is, you got to plug that in for k for each point. For j, you got to do the same thing. For n, you got to do the same thing, and you're going to get your series of points. So you want to find and write out your points first, and then go through and graph them. Okay, next one. Let's look at like number 10. On number 10, it says my x has to be 2, but my y is defined as everything less than or equal to 5. So looking at this, it says my x has to be 2, so my x value has to be 2, so it's going to be somewhere on here, but my y value has to be less than 5. So if I find what 5 is, 1, 2, 3, 4, 5, so it has to be less than or equal to means closed circle, and less than that, so it has to be everything smaller than that. And so that's going to be the graph representation of that relation. Let's try number 15. For number 15, it says I have everything represented for x and y, but x has to be greater than 2. So that means if I visualize this correctly, if x has to be greater than 2, or -2, so we'll find -2. -2 is somewhere along this. I did a dashed line because it can't include it. And x has to be everything greater than that. Now there's no restriction on y, so it's also every single possible y value. So if I'm going to say x is greater than 2, that's literally this entire area here. It's everything. X has to be greater than 2. It can be any y value, it can be any x value as long as it's greater than 2. And so every single possible point that's on this region, that's going to be answered. And so when you shade that region, just kind of remember, is you're saying it's every single point. There's an infinite number of points on this space, and you're saying any single point on this space is going to work. Let's kind of verify that. Why not? What if I pick this point right here? Let's pick 1, 0. So if I plug in a 1 into here, 1 is greater than -2. That's true. There's no restriction for my y, so boom, that's a point that's going to work. Okay, so let's look at another one. 21 through 30, it says describe the given relation either using either the roster or the set builder method. So like 21, For this one, all you're going to have to do is you're just going to just sit there and, okay, my first point looks like it's -4, -1. My second point is -2, +1. So right, so all you're doing is just going over here, -2, +1, and so there's my point. This one right here is 0, +3. So 0, +3, and then the last one, it's 1, 4. And so that's my answer. And so that is the roster method. I've listed every single thing. Let's try number 26. That one looks fun. All right, so we know that it's a point, right? It's 2 dimensions. It's a region, so it's not saying that like x has to be specifically something and y has to be specifically something. But it looks like from this graph there are no negative y's. There's only positive y's. So that means I'm restricting my y's here. And so I can say that my y is going to be greater than or equal to, and that looks like 0. Now the reason why I did equal to is because it's a solid line, right? It's not a dashed line. If we compare it to this one, see how that one's a dashed line. So that one's going to have an issue there. But this one's a solid line. There's no dashed line. And so we can do that. So the relation F equals that. For this one, I could have said the relation A is that, the set A. So now let's look at some of these. Number 41. We have the graph y equals x squared plus 1. It says find the x and y intercept of the graph if any exists. So this is identical to what we did in the lesson. So to find the x and y intercept, well, you know what? Let's do number 45. I think that one might be even more fun. Let's try that one. So we have y equals the square root of x minus 2. So to find the x-intercept, right, we have to say that the y is 0. So I'm going to get 0 equals the square root of x minus 2, square both sides, and so I get 0 equals x minus 2, add 2 to both sides, 2 equals x. So that means that my x-intercept is going to be 2, 0. Then to find the y-intercept, I have to set x equal to 0. So doing that, I'm going to get y equals the square root of 0 minus 2, which is y equals the square root of, it looks like root 2i. That's imaginary, so there's no, not a y-intercept. Okay, so we only have an x-intercept. And then I'm going to let you guys do the whole create a table of sample points and graph that your own equation. I think that it's a little time consuming, but I know you guys can do it. Let's plot the sample points, create a rough sketch. Okay, let you guys do that. Let's test for symmetry. Let's do that. So testing for symmetry, we said that we can be symmetric over the y-axis, and if we're going to be symmetric over the y-axis, okay, if we imagine it, right, it's being symmetric over here, my x goes to negative x. So I have to plug in a negative x in for my x. So doing that here, I'm going to get y equals the square root of negative x minus 2. Well, those are clearly not the same. They're not, and so it's not symmetric. If we're going to do symmetry over the x-axis, then I have to plug in a negative y. And so if I plug in negative y equals the square root of x minus 2, those are also not the same. And so because those are not the same, then it's not going to be symmetric over the x-axis. And then the origin, if I do both, negative y equals the square root of negative x minus 2, that is also not the same, so it's not going to be symmetric over the origin. And so that's pretty much the process to follow, and you go through and do them all, and you should be able to do it. If you have any other questions, though, I know I kind of skipped some of these, like being able to create the table. I'm assuming you guys know how to do that, but please let's address it in class if you guys have any questions of that. Hope this helps. Have a good day.